This is the next video in the function set of videos. In particular, in this video we're looking at a past examination question, and the one we're focusing on is 2014 paper 1, and we're looking at question number 9. This question says, a small rocket is fired into the air from a fixed position on the ground. Its flight lasts 10 seconds. The height in meters of the rocket above the ground after t seconds is given by h is equal to 10t minus t squared. So h is equal to 10t minus t squared. For this, h stands for the height and t stands for the time. Part A of this question asks us to complete the table. So to complete the table, I'm going to do a little bit of rough work here on the right hand side. So again, we know the function h is equal to 10t minus t squared. First thing we need is t equal to 0. That's going to be, which gives us an answer of 0. We then need t1, so it'll be h is equal to 10 by 1 minus 1 squared. H then is going to be equal to 9. T is equal to 2 will be h is equal to 10 times 2 minus 2 squared, which is going to give us an answer of 16. T equals to 3 is h equal to 10 times 3 minus 3 squared. That's going to give us an answer that h is equal to 21. T4 then, we get h is equal to 10 times 4 minus 4 squared. That's going to give us an answer that h is equal to 24. They've done 5, 6, 7, and 8, so we need to get t of 9. So that's going to be h is equal to 10 times 9 minus 9 squared, which will give us an answer of 9. And the last one then, t10, which is going to be h is equal to 10 times 10 minus 10 squared. That's going to give us an answer that h is 0. We have all the answers then to fill in the table. So when t is 0, h is 0. When t is 1, h is 9. T is 2, h is 16. T is 3, h is 21. T is 4, h is 24. T is 9, h is 9. And t is 10, h is 0. So I'm just going to fill that into the table really quickly. Part B then says, draw a graph to represent the height of the rocket during the first 10 seconds. Again, take your red pen and you can put in the dots using your red pen. I'm going to zoom in a little bit to make it a little bit easier. So when time is 0, height is 0. When time is 1, height is 9. When time is 2, the height is 16. Time is 3, the height is 21. When time is 4, the height is 24. When time is 5, the height is 25. Then coming back down, we can fill in all of these points. Is 0. The last thing you need to do then is just join the points together. And you'll get an answer like that. Then in part C, it says use your graph to estimate the height of the rocket after 2.5 seconds. What you do then is you go to 2.5, you go all the way up, so you draw a line, and then you go across, and you should get an answer of 19. And of course, this is the height, and the height is in meters, so it's going to be 19 meters. Find the time when the rocket will be at this height again. That's then a continuation of the last question, so you just continue with the line straight across, and wherever it hits on the graph, you come straight down, and that will be your answer. So it will be 7.5 seconds. Then it says the coordinates of the highest point reached by the rocket, and the highest point is the highest section of the graph, which I'm colouring it in green, and the point for that is going to be 5 seconds, so 5:25. Part D then asks us to find the slope of the line joining the points 6, 24 and 7, 21. Now we know the slope formula, so m is equal to y2 minus y1 over x2 minus x1. That's in your formula and tables booklet. We then can label our points, so this can be our x1, y1, x2, y2. So the slope then is going to be y2, which is 21, minus y1, which is 24, over x2, which is 7, minus x1, which is 6. Then we get m is equal to 21 take 24, which is going to give us minus 3, and then 7 take 6 is going to give us 1, so the slope here is minus 3. Then part 2 says, would you expect the line joining the points 7, 21 and 8, 16 to be steeper than the line joining 6, 24, 7, 21? Give reason for your answer. So we have the points 6, 24, 7, 21, so that's joining 6 and 7, and 7, 21 and 8. So we're talking about two sections of the graph. So I'll highlight it in. So where we have 624 and 721, I'm going to highlight in green, and you can see that here on the graph. And then we're talking about where we are highlighting 721 and 816, which is this point here. So looking at that, you can kind of see that it is much steeper. So it is steeper on the graph. However, to be definitely sure, you should always get the slope of a 2. So the slope is m is y2 minus y1 over x2 minus x1. We've got the slope of 624 and 721, so we need the slope of 721, 816. So that's x1, y1, x2, y2. This will become y2, which is 16, minus y1, which is 21, over 8 minus 7. That then will give us an answer of, so 16 take 21, you're going to get minus 5, over 8 take 7, which will give us 1, so of course we'll get the slope is minus 5. So the slope of the points 7, 21 and 8, 16 is equal to minus 5, and the slope of 6, 24 and 7, 21 is equal to minus 3. So that's perfectly fine what you've done here. So yes, it is steeper on the graph. You can always say as well to look at graph. That brings this question to a close, and then it's the end of this video too.